Like saturation, there are maximums. We can saturate all of the binding sites so that that transporter cannot pull back fast enough. Glucose being the one that shows up in urine in the diabetic because their blood sugar is so high, there's so much sugar in their urine, the transporter is overwhelmed. It cannot pull back all of the glucose, and glucose winds up in the urine. So glucose in a cell, here is a GLUT transporter. So when that transporter is there, glucose goes from high concentration to low concentration across the protein carrier, and then the cell immediately turns it into not glucose, so that there is low glucose in the cell, so that glucose is constantly moving in. Remember, we put that phosphate on it, and then we start doing something with it, so that glucose will go out of the blood into the cell promptly. All right, tell me about what you just learned about facilitated diffusion. What did you understand about facilitated diffusion? Good. Nobody said A, but some people did pick D. Facilitated diffusion does not require energy. That's the only wrong answer on there. So A and D cannot be right, because facilitated diffusion is passive, no energy needed. But the other two are correct. So it's going to have help getting across the membrane in the form of a protein, and that protein can be specific as to what it brings across. All right, now we have to talk about osmosis. And osmosis is a special term that is diffusion, but it's the diffusion of the solvent. Remember, we talked about the solution, solute and solvent, and for us, the solvent is water. So osmosis then, for us, is the movement of water. And water goes from high to low, just like everything else that diffuses. So it is a passive process. In fact, water is never actively transported. I love that. We don't have very many nevers or always in physiology. So take it. Water is never actively moved. It moves passively from high concentration to low concentration, always. Now, water can diffuse as individual molecules across the butter sandwich because the butter is loose enough to let individual tiny molecules of water get across. Even though water's polar, it can shimmy its way across the butter. I'll make sure you got that.
Oh,
okay.
No, you're out of the frame.
I
I'll have to do
got
it
it.
again.
Okay.
Oh, good.
Okay.
Okay.
But if we really want to move water, we put a pore in the membrane, cleverly called an aquaporin. And this is what happens in the kidney. This is what antidiuretic hormone is going to do, is stick in these pores so we can move water quickly. From your book, this membrane is permeable only to water, which are the blue balls. And the big pink balls, they can't go through. So water moves from a high concentration of water to a lower concentration of water. Notice that there's 4 pink balls, 2 pink balls, but the balls cannot cross, but the water can. If there's more pink balls, that means there's less water. So water moves from high concentration of water to low concentration of water. This lab will help you understand that, help you absorb that information. So, PowerPoint magic. This is a semi-permeable membrane. It's permeable only to water, not to sodium. So, is water going to move? Which way is it going to go? Nope, can't do that. Turn the horizontal. Yep, water moves. We're going to do this in the collab today. Not this specific one. I'm actually going to do this one. So we have these little bags that have sugar in them, and we put them in a beaker of pure water. So now there's less water in here because there's more sugar in here. So water moves in and the bag gets bigger. When we put twice as much sugar, there's half as much water. So water really moves into that one and makes the bag swell. And then osmotic pressure is how bad water wants to move. The lower the level of water, the faster it wants to move. You can actually calculate that if you've had Chem 2. Go crazy. I don't make you do that. All right, movement of water. Oh, I lost my little button. Well, here, just tell me. What is the movement of water called? C, osmosis. Now we have to talk about moles. Because we have to talk about how the hypothalamus knows whether or not you need to drink. A mole is just another unit of measurement, so don't get freaked out, just another unit of measurement. In the 1500s, is when Avogadro figured out, he's the one that contributed this information and they named it after him, that 1 mole of an element contains 6 times 10 to the 23rd molecules, or atoms. All right, pull out your periodic chart of the elements. Gave you chapter 2. All right, now look at the atomic weight, which is the number underneath the atomic symbol. She needs some sharing. Here, let me facilitate sharing. So you see the number underneath? All right, let's look at